Hello class, this is Panos. Today we're going to have another screencast, and this time we're going to see how to use the has a relationship. So we're going to have two classes, one using the other, and we're also going to see some simple if statements. Okay, so let's start. We're going to go initially and create a new folder for our new application, and I'm thinking of creating something which relates to professors and their offices. So basically there's going to be an office class, and then the prof class will have a office. So each professor has an office. That's the idea here that we're trying to implement. Okay, so let's open a terminal and navigate into the folder that we created. So it's profs and offices, so we changed there, cd. Now that we're in there, it's empty, and we'll use gedit and create the first class. Let's call it office.java, and we use ampersand to start on the background, and that allows us to write the code there. Now we have the file here. We start with the usual stuff, so public class office. Remember, the name needs to match, the name of the class needs to match with the name of the file. And let's type some fields here. So we're gonna need let's say a number to identify that particular office, and also let's say that there is a door note, a note on the door for each office. So we can suppose that each prof is actually able to write something in there. So initially in our constructor we're only going to deal with the number, and suppose that there's no note associated at the moment with that door. So number equals number in, and then we're going to say door note equals the empty string. So just two double quotes, one after the other. That means there's nothing in there. Okay, let's create an accessor method for that number. So public int get number, and then we do a simple return number. We're also interested in handling that door note. So first of all, we should be able to get it. So public string get door note, and we should simply return the door note here. Nothing special about that. And let's also have a setter method for this door note, for this field. So void set door note. Since it's a setter, it should have some sort of input which will be set to the object. So string door note in, and what we do now is we say door note, let's type it, door note equals door note in. Okay, and that concludes basically the first class. It's quite simple. Let's try and compile it and see that it works. Javac office.java. Okay, yeah, no problems. So now we can move on to the next class. We're going to have a prof class, and this class is going to basically be having the has a relationship that we've discussed in class so far. So it's going to be having an office. Each professor has a office. That's the idea here. So let's write the fields that the class prof has. We can say that each prof has a particular name. So string name, well, let's make it private, not just string name. And we also have private office, and this implements the has a relationship we've discussed. Okay, for our constructor, again, public prof, it has to be the same as the name of the class. And let's say that initially it's just the name of the prof that has been created, because the prof might be new and might not have an office yet or something like that. So let's say that name equals name in, and then we're going to use the special null value that we've discussed in class to store for the office, to signify that there's no office assigned yet for that prof. Nothing yet. Later we'll be able to assign something, of course. Okay, let's continue with some other methods here. We're gonna need to be able to say post a note, that is once we get an office, but this is one of these methods that we'll need. We're gonna have a note in, And now remember that the note is associated with the office itself. So first of all, we need to check if the office is null. If the office is null, there's nothing to post the note to yet, so we cannot do anything. So if the office is not null, then we can use the method that we wrote on the office.java. There it is, set door note. So we copy paste that thing and we paste it on the correct spot. So set door note, and there we can pass note in. So notice here how the prof class is actually using the office has a relationship that it has. It's using this reference to the object to actually pass that note in. But we said that initially we don't have an office, so we might as well write a setter for the office. So set office, it needs to get an office input. So let's say office in, which is the new office that will be allocated to that particular prof. So office equals office in. So now we actually have a connection, an association between the two. Okay, let's see some more methods. We might want to get the total information that relates with this prof. So for that, we're going to create this getInfo, which is pretty much like the toString methods. It returns a textual representation of the prof. And let's break it down into multiple things. So the first case here is that the professor hasn't been assigned an office yet. We would simply need to print something simple, like professor followed by the name. So we store this on this variable info, and we return it. Initially, the office is null, so we should take care of that case. So if office is not null, we should be able to do more stuff. Otherwise, we shouldn't do anything. And actually, no, let's write some more stuff for the office null case. So we can say that the prof doesn't have an office yet. So let's write that. So that adds it to info, and as you can see, we're turning info here. So we gradually make what we want to print. Otherwise, we can say that this prof has been assigned a particular office. So let's say that prof X is located at office, and at this point we can request the name of the office, and we do that by using the name of office of the reference, and then dot. We travel to that object, and we can then get the number of that object. So office.getNumber. And now there's one more case that we want to take care of. What happens if there is a door node, and we can use the door node. So again, this has a relationship. First, we check if there is something posted. So we can say if office.getDoorNode, which gives us access to the door node of that particular office. And then we should say if this is not equal to the empty string. Notice here that I made a mistake in the beginning. I corrected it. You do not compare with equals and not equals. Otherwise, the comparison refers to whether they point the same object or not, not if the contents are the same, which might lead into trouble. So we should use the equals here and say not. So if it doesn't equal the empty string, we can append an extra message there which says whose door says, and at this point we can simply get that door node again. So office.getDoorNode, we copied from before. We should put a semicolon there, and that should do it. So let's save that and give it a try. Let's see if it compiles properly. So javac prof.java. Okay, works fine. So now we should also write a driver test to see if all these things work. So again, gedit test prof office, well, prof off.java. Let's write it office, and let's start gedit again. All right. So again, the usual stuff: public class test prof office. Again, has to be the same name as the name of the file. And here we need a main method. So public static void main. This is standard. String and args. You can name the variable as you want. We usually name it args. It doesn't matter. So initially, let's create some offices. And so what kind of offices? Well, simply 3 offices would suffice. I don't think we would need many more than that. So create, no, create profs after all. Well, change the plan. I'm actually recording it afterwards. So professor prof1 equals new professor, and let's give nice names. Albert Einstein would be a nice name, I guess, famous prof. And let's remember how the constructor of the professor needs to be invoked at this point. So let's find the professor. Well, no, not professor.class. We need to open professor.java. This is where the code is. And as you can see, we're just sending the name for the constructor. So we're good. We don't need to send anything else. And we also named it prof, not professor, which is why I need to correct it at this point. And let's create 2 more profs. So prof2 and prof3 for the variables. And let's put Alan Turing here, since we're in computer science, so we might as well use one of our own. And let's put another famous physicist here, Stephen Hawking. Okay, now we have 3 profs. I guess we're ready to start making offices now, which is the next part. So let's write a comment, create offices, not rooms, and office of 1 equals a new office. And as before, we'd rather go back to the office and ensure that we're using the constructor properly. And as you can see, the constructor requires a number in, so just an integer. We need to set an integer there. So let's type 101. That's enough. So let's copy this 2 more times and create 2 more offices. So let's say office 2 and office 3, and we're gonna give 102 and 103. Okay, nice. So we have 3 profs, we have 3 offices. So let's see what happens if we display the current information that the profs have. So for that purpose, we will need to use the getInfo method from the profs themselves. So system.out.println, and then let's go and write prof1 dot, and ensure that we're actually using the correct method. So let's remind ourselves which one it is. So it's .getInfo. So let's copy it. GetInfo. So prof1 .getInfo, and we open and close parentheses. Remember, this parentheses refer to methods. We copy this 2 more times, and we say prof2 and prof3. So now we have the full information of all these 3 profs. So let's compile that new test prof office Java class. Okay, compiled, no syntax errors. Now we can run it, and let's see the outcome. Okay, all 3 of them are there, but they do not have an office yet, which is exactly the expected outcome. So far so good. So this is the case where the office is null. The constructor started as null, and as you can see, if office is null, then we print doesn't have an office yet. Okay, let's make it more interesting now. Let's try some more stuff. Let's do some assignments of offices. So let's give some profs some offices and see how it'll work now. So let's give prof1. Yeah, first of all, let's ensure that we're using the correct method. So set office, we copy paste it, and then let's give office 1 to the first prof, and also let's give to prof2 the second office, and we can copy paste this the display information and see what happens now. So we should just see the first and the second prof having offices. Yeah, you can actually see the first 3 lines are the previous stuff, and then the next 3 lines are the new stuff that we printed, and you can see that 101 and 102 are there. I'm just gonna add an extra line to make this appear a little bit more pretty, because it starts getting convoluted. So system.out.println, just an empty line. Okay, let's try some more stuff now. Let's start posting notes on doors. So it's the profs that post the notes, but they post the notes on offices. Keep that in mind. So we copy the post note method that we created inside the prof class, And since we're talking about professor number one, which is Albert Einstein, we're going to post his famous equation, E equals mc squared. Probably the most famous equation ever written. Fixing the second display part, and now let's copy all of the display things after making the note. We compile, and we run again. And now you can see that Professor Albert Einstein has an office whose door says equals mc squared. So again, the printing is performed as we were expecting it. Okay, let's try one more thing. Let's spice things up. Let's start moving people around. Let's do some swapping of offices. So let's move Prof 1 to office number 2 and 3. Okay, so Prof 1 dot set office to Off 3, and then Prof 2, let's move this guy to office number 1. That should be good. Okay, and now we can copy paste again the display information, and now watch it. Although Einstein was the guy who posted the note, because the note is associated with a particular office, it's going to be printed on somebody else's door now. So look, Alan Turing has office 101 and his door says equals mc squared. So in the beginning it was Albert Einstein, but now because we've moved the office to Alan Turing, it's his door that says E equals mc squared. You see, this relates to how things are stored in there. It's the pointer that changes to the to the new office. It's not that we're actually changing data directly inside the prof. Okay, I hope that helps you. I'll see you tomorrow in class.